Imagine an Earth observation satellite that actually does not have any connectivity to Earth. The only connectivity that Earth observation satellite has is to that infrastructure, which is in orbit. That Earth observation satellite does not need to look for a ground station. It can focus on doing what they need to do, is to take images, store them, process them, and then upload them to the network. That's a change. And by the way, because that network is available everywhere around Earth, then the Earth observation satellite will have real-time connectivity in orbit.
Hey Space Watchers, this is Space Cafe Radio, your channel about trends, awesome events and interesting people in the space sector. Imagine a data cloud in space. Imagine Earth observation satellites that don't need a direct data connection to Earth. Imagine you can have your mobile and data connectivity in the remotest areas of our planet and beyond. All that sounds like science fiction, but we are almost there. Avi Shabtai, CEO of Ramon.Space, took me on a foresight journey to discuss the infinite opportunities that open up for all of us in space today. This episode is produced in collaboration with Ramon.Space. Join me in this thought-provoking conversation. I'm Thorsten Kriening, publisher of SpaceWatch.Global. Lean back and enjoy this episode. Avi, great to have you back here in our Space Cafe and this time in our radio studio. So a very warm welcome. The last time we spoke at the Space Symposium quite a while ago about your company and we touched a bit on your services. But before we dive into that, I want to pick your brain as an industry expert. I would like to listen to your current market assessment. Where do you see the global space, particularly the satellite industry, stands today?
Hi, Thorsten, and thanks for the opportunity to be again at Space Cafe, and good morning. Where do I see the industry? There's so many things that happens in the industry, and almost every day you hear something else that is moving. And I think there is a very dynamic industry. It's waking every morning. Okay, what's the next surprise of today in the space sector? But I think if I have to look at the top level, I would say that we see definitely in the last, 12, 24 months, that notion where you see that the space becomes more and more strategic in many aspects. We see the move of many countries that were not involved in space towards the space sector, and really the understanding that space is really important, and it's important to have assets in orbit, giving it because of commercial reason or geopolitical reason. And we see how space starts to become, or the use of assets in space starts to become critical in some aspects of that, with several geopolitical conflicts suddenly where the use of space assets became very important for certain countries or entities. I think the other phenomena is I see an increase in the new entrants to the space sector. Partially because there was more funding available. We know that the government involvement in the sector continue to increase. You see the funds coming from pretty much all the governments that are interested in space, and the funds flow in, and that enables more innovation and also new entrants that are moving in for new application and services. And I think that's very interesting because that shows that the industry is moving now towards big innovation phase of technology. And it comes along with the lower cost of access to space. And that leads to the fact that if you have innovation on what you want to do and you can access space in an easy way, then definitely you can start delivering more services from space or application for space and use space in a more efficient way, in ways you were not using it before. I would also mention that among the traditional players, we also see quite a lot of consolidation, which I believe will lead to more consolidation in the ecosystem in the next years. But that's, I think, tied up to business models of the traditional players and how they play their role in the industry. That's what I see, and I think that's important to note.
When going to your website, your tagline on the website is, imagine a universe of possibilities where computing in space is infinite, flexible, and accessible. What I think it's a very bold statement. Where do you see these big opportunities?
I think that when we build the company, we build it in a way that we wanted it to deliver systems that can go into satellites and enable programmability and flexibility and really endless opportunities, right? Where we see the current big opportunities, I think one is the the communication market, new constellations. I think you start to see more and more players moving towards a realization of constellations, new entrants as well as established ones. We also see that quite a lot of them are moving towards 5G implementation. And I think 5G in orbit, or what's called 5G non-terrestrial network, can really change the position of space communication, which will eventually turn space communication to be part of the overall, I would say, mobile network that we know on Earth, like the terrestrial network. And I think that's very important for the industry and will really change the way that we look at space connectivity or space communication. I think that it will also evolve to different services that you can actually implement from space, because once you work, for example, in 5G from space, that opens the door for multiple applications because you have already devices on Earth and you have technology on Earth that is relatively easy to be implemented. It's relatively easy to build an end user terminal all of the sudden, and the ecosystem is ready for that. I think the other big opportunities we see is the new types of remote sensing applications, not just the space imaging or what's called Earth observation, but more sensing of electronic signals and getting more data from what weather sensors and so on, getting more data from collecting data from Earth. A nice connection to 5G in this domain is really networks that are being built in orbit to collect data for IoT reasons. So you can see here a fusion between, and a lot of them are going towards 5G IoT. So you can see the fusion between the communication network, for example, and the sensing network all of a sudden, using the same technology for both aspects. I think the last big opportunity will be, and it might be actually the biggest of all, if I look at the future plans of ours, and I think other players in the space, is really what's the evolution of space networks. And space networks, which will lead eventually to what we call the cloud in orbit, or the build out of data centers and services in space. And I think that's really a big opportunity. It takes time for it to be realized, but you can see the steps in the evolution. You can see actually very similar to what happens on Earth. You start to see the expansion of optical connectivity, which happens on Earth, around 20 years ago. You started to see fiber connectivity all over. Suddenly everything can be connected relatively in a simple way. Once you have points that can be connected over optics, you can make them smarter and then can start delivering services. And I see that evolution of space networks, multiple networks in space that will deliver service in orbit or to Earth itself.
Wow, that's a lot. Let's try to unmantle that a bit. How do you define a constellation? Is it 2 satellites, 3 satellites? Is it 500? So when becomes a satellite, a group of satellites, a constellation, in your opinion?
I think a constellation, it's not necessarily defined on the number of satellites. It's whether the constellation, you have a cluster of satellites that are aimed to deliver the same service for the same application and network. Then you have a constellation. It could be 20 satellites because it's an IoT, non-real-time application, store and forward type of application. It can be, of course, 500 satellites because you want to maintain continuity of service. So I don't think it depends on the number, but really, if you have multiple satellites that are doing the same mission and have some correlation between them, then I view that as a constellation. Naturally, there are players that launch, for example, Earth observation satellites in a constellation mode. Depending on the connectivity between them, you can look at it this way or that way. But I do believe they are referred to as constellations as well.
Tell us a bit more about where Ramon.Space fits into this picture that you just draw about the market and about the opportunities. And maybe you can give our audience also a bit of history.
I think if you want to look from the top level at Ramon.Space, we build computers for space. Let's make it simple. We started as a company that builds semiconductor for radiation hardened semiconductor for space, focus on processors for space. And then we realized that it's not enough just to provide the processors, and both from business and market dynamics, we want to provide the full computing systems. And then we came together with the fact that we actually realized that the use of data in space is going to increase, and we want to provide some sort of a computing infrastructure for space that will actually enable others, or will lay the foundation for others to grow on top of that by developing software application and services. Now, when you do data in space, so it's very simple, right? If you want to provide something that supports data in space, you need to provide a breakdown of storage functions, processing functions, and you move the data. You can move it, you can store it, you can process it. And that's how we build the company. We build the company about those three anchors: storage systems, processing systems, and communication systems. And the way we look at it, we are an infrastructure provider. We are not the one that will eventually develop the full application. And we want to deliver this type of systems that go eventually into the satellite to our customers. So everything that I mentioned before about opportunities, they can actually take those systems and they don't need to start from scratch building the system. They can already have the foundation and then grow from there. And that's our role. We believe that space computing is a necessity. We believe that space computing is happening and will grow significantly. But in order for it to grow, you need players like Ramon.Space that can actually provide this type of infrastructure, because that's what accelerates the market. I'm always using the example of the cloud service providers. What have they changed? They changed the way, look at the SaaS industry, how it grew so fast in the, let's say, in the last 15, 20 years. Why? Because the foundation of the infrastructure, I'm calling it computing infrastructure, but that's essentially what it is. Those data centers, computing infrastructure, was already there. Everything was there. They could just focus on building on top of that their own application or their own SaaS service or technology. And that's what enables the acceleration of the introduction of services, of new companies that emerged. It's really having the foundation of infrastructure. And that's our role in this segment.
You said something what really made me listen very carefully: cloud in space. I never heard that term talking about computers in space, what you just mentioned. Can you connect these dots for me? So how do I get my cloud from a terrestrial cloud infrastructure into space? Because at the moment on Earth, we have this massive infrastructure. If we talk about the giant cloud providers, they have massive data centers, which I think at the moment consume about 5% of the world energy as well. So to bring that into space is something what, at least for me today, is not imaginable. So how to go there?
Yeah. So let's imagine. Okay. So imagine that you have a network of satellites in orbit that comprise, from an infrastructure perspective, a multiple micro data center. Each of those satellites would be, let's say, a micro data center. And this network will be connected with optical connectivity and create some kind of a mesh around Earth. Suddenly, each satellite by itself is a micro data center. It doesn't have to be the huge data center that is available on Earth. And let's imagine that you run on these micro data centers the same infrastructure that you run on a terrestrial cloud provider infrastructure, whoever it is. Then all of a sudden, you have a few advantages, right? You can actually deliver the cloud service from that microsatellite to a user in space, and we'll talk about it in a second, or you can deliver it to a user on Earth. Now, because it's a mesh of satellites that are connected, they can have multiple entry points to Earth. So they will have continuous connectivity, unrelated, by the way, to where they are, and unrelated to where the satellite that they're delivering service to is. If we continue one step forward, imagine an Earth observation satellite that actually does not have any connectivity to Earth. The only connectivity that Earth observation satellite has is to that infrastructure, which is in orbit. That Earth observation satellite does not need to look for a ground station. It can focus on doing what they need to do, is to take images, store them, process them, and then upload them to the network. That's a change. And by the way, because that network is available everywhere around Earth, then the Earth observation satellite will have real-time connectivity in orbit. You can compare it to running with your smartphone looking for a Wi-Fi hotspot, which is what happens today to the Earth observation satellite, versus connectivity to your 5G network, where you have connectivity everywhere. So that's where I see that evolution happening. And there will be some fusion between the terrestrial cloud infrastructure and the space cloud infrastructure. By the way, we're being asked many times, and why, if you just have connectivity, you can deliver all the service from the ground, right? From the data centers on the ground. But actually, when you speak to the data center providers, they tell us specifically, no, there are some, because of delays, because of the time that it takes, sometimes we need the information much faster. So there is a good reason why to have something that is in orbit that is connected immediately and delivering to his service within a very short time. So that's how I see the expansion of cloud in orbit. My view on that, it's going to happen. I'm coming from the data center market, from the terrestrial data center market. So I saw the expansion of the data center on Earth and the pace that they were moving. I see the similar trend happening at the moment in the space industry. That's how I see it evolve.
It's an interesting thought. What you just described is this next level of a data relay satellite that we have seen for years to enable the connectivity. And I think the example you made with the Earth observation satellite that does not need a ground station per se, just using this network is absolutely striking. And I like it. It's very interesting. So can you give us, please, some use cases that you're working on today, missions that you are involved in where your hardware, your solutions are in space?
We are working on several use cases that are very interesting. First of all, I would say in the fields of Earth observation and remote sensing, where our system used for really doing the in-orbit processing, but it's all done in software and it's all upgradable. So for example, we can deliver units that an Earth observation player can run the processing in real time, as we spoke before. And not only that, can change the functions of the Earth observation satellite while in orbit. And that's for our customers becomes like a critical function because they can actually use the satellite in a way more efficient way. We have customers that are using our storage systems as their core, collecting data and either data or images. I think the other use cases, as I mentioned before, one of, I think, the biggest opportunities in the market is the drive towards 5G and the build out of 5G networks in orbit. So this is an area where we're heavily involved and we're investing quite a lot in that specific use case. Now, when I say that use case in specific in the 5G domain, or I would say in the communication 5G domain, there are several use cases. It's not just everything is the same. We see customers that are building networks for 5G to support the automotive industry, really focused on the automotive industry. We see customers that are using 5G for, of course, the underserved area or maritime or in-flight. But we also see how some customers are looking how they can leverage 5G connectivity even into suburban areas, dense areas where they can leverage the 5G actually to possibly offload the mobile operator capacity by delivering the service from orbit. And that could actually turn the 5G to be a very interesting solution or a very interesting area for the space sector to become really a part of the overall terrestrial mobile connectivity network. So I think that's, would say, the areas that we are focused today in terms of use cases. We're very busy with quite a lot of what I mentioned, and it's quite a lot to have on one company to provide.
I'd like to come back to the 5G in space you just mentioned. Tell us a bit more about that and this general challenge we are seeing at the moment, this ongoing spectrum debate with C-band use. And there was recently a report about the ITU about 5G, especially in the established areas today. So it seems that we are lagging here behind in terms of implementations for rural areas. And also, why can't I use my mobile phone today for calls via space? Maybe you can help to dismantle that a bit for me.
Regarding the question why you cannot use your phone for calls, just for that, it's always what we call a combination of the availability of a network above you, availability of the frequency, and the availability to have, we call it link budget, but really to have a good connection, right? They can all be in one way or the other solved, but of course they all have their limitations in what way you can actually use it and what's really would be the total capacity you can and speed you can reach to your mobile. But say that the 5G NTN would definitely has regulation and regulatory challenges around frequencies, landing rights, and these will need to be resolved. I think part of it is going to be resolved when there will be a realization by the mobile operators that the 5G NTN actually helps them significantly in offloading and saving them actually from the need to put more money and CapEx into infrastructure. I think then it will be easier. But regulation is regulation, and there will continue to be some debates about frequency and landing. I think we've seen it in the mobile world itself, in the 5G or 4G, and before that in 3G. I believe it will be resolved with time, and as long as there will be good business justification, there are going to be solutions for that. I think that the 5G itself, people are asking, why do you even want to do 5G from space? Why don't just continue in the regular way? From my perspective, it's obvious that the move to 5G is needed. And the reason is that the space sector is, despite the fact that we launch satellite, is still small compared with the mobile industry. The amount of investment in this industry is much bigger than in the space sector itself, in the technology development. And the space sector can enjoy the ecosystem of 5G. If you look at, for example, user terminals, the ability to build user terminals, the technology is available. The devices, the RF devices, you can build terminals based on 5G. 5G non-terrestrial network is a standard, and it's actually part of the 5G 3GPP definition, which actually make it, once it's a standard, it means you can deploy standard solution with interoperability. All of the sudden, space is open. You can connect to one network and move to the other network if you want, and do roaming between two. Think about roaming between two space constellations, okay? Things that you would be able to do that. And I think that's what eventually will drive, is really this economical power that you can leverage a whole ecosystem of 5G to support the space sector. And as I mentioned, the use cases around, of course, the underserved area, in-flight connectivity, and bridging the digital divide, that's obvious. But that those specific applications for targeted sectors like automotive industry, fleets, and so on, I think will also drive that. And not forget the IoT, which is also could be based on the 5G network as well.
I have one question on that, because the mobile sector is obviously earthbound, and you have the territorial regulation in the countries, because mobile operator operates in a country or then cross countries. So in space, we have a different situation. How do you connect that? Who owns that? Which regulation will then apply? I asked before, can I use my mobile for calls today with space? No, I can't. But what I can do with my iPhone is I can send my SOS signal with that very low bandwidth due to the link budget you just mentioned. But we see in the debate that many of these operators are talking about that already. SpaceX, for instance, has a deal with T-Mobile in the US. We have AST and so on. So it's ongoing, this debate. How can that merge together? And I absolutely agree that the mobile sector on Earth is much bigger than the space sector at all.
I think we should differentiate between the type of service you can receive, which is it text or voice calls or data, which depends more on the capability of the network, and what network can you register to, right? The way I would look at it is that let's assume that I solve the landing right and the frequency allocation, which we spoke before about. Then it becomes a roaming discussion, right? So if you can move from your mobile operator network to a satellite operator network, as far as you're concerned, you don't know that it's a satellite network, right? It's just their name that appears on the screen. And then you connect to it and you get whatever service they can deliver, depending on the link budget, capacity, and so on. That's, I think, how simple it could be. The way I look at it is roaming agreements between different suppliers, different space suppliers, but the mobile operator have agreements also among themselves, right? When you move between different countries. So there is another country, which is called space. And whenever you connect to that network, and the nice thing about that country is that you can have it anywhere and everywhere, which could be really appealing to certain applications. For example, if you can imagine, let's pick up, just for sake of discussion, the automotive industry. And let's say that one of the automotive manufacturers wants to be connected to every vehicle that they send out of the factory on Earth, right? Today, they can do it by having, let's say, a cellular modem in the vehicle, but then they have to, either them or through wholesalers, to get to an agreement with each mobile operator in each country and run through their networks. So imagine that they have another global mobile operator called Space whatever, and they connect to them, and they don't need to connect to any other specific country network. That's a change, right? It suddenly opens the door for them to deliver new services, to connect to all the vehicles very easily. I don't know, maybe it's even cheaper to do it this way. But that's how we should think about it. It's just another mobile network. The advantage of it that it's global.
Listen to you and remember the tagline on your website that I mentioned before. I think I get a sense when you talk about these possibilities are infinite, but are there any limits for you, for your growth, for your own applications in space or not?
I don't think it has as a limit or not. And I just go back to the example that I gave before. We are building a computing infrastructure. When you build computing infrastructure on Earth, would you have really limits or is it really infinite? How many companies were built out on cloud infrastructure of the cloud providers, right? Probably a very big number. So that's how I see ourselves because we're providing an infrastructure. We're not tied up to one application or one segment. And as long as the space sector would want to move forward, and I do believe that the space sector will move forward with using this infrastructure to provide more solutions and applications, then we will continue to grow. We are very focused on, as I said, not tied ourselves to a specific application, but more really providing the foundations. And when you're building foundations, you can grow significantly because then others are basically using it for their growth. So we, in a way, leverage on the others that want to grow and help them to grow.
Before we come to an end, I would like to ask you, where will we see Ramon.Space in the next decade? Where do you see Ramon.Space in that time frame?
In the next decade, we want to be the most dominant players whenever you need to go and deploy space computing. And we want to see ourselves in many satellites around Earth delivering the services and to be a significant part of this big, I would say, mission of computerize and digitize space and really to be the leader. And that's where we see ourselves. That's what we are doing on the day-to-day basis. In a company like us, you do a lot of small things that one after the other are building a bigger thing. And sometimes whenever I speak with the team at Ramon.Space, after a year passes, so during the year, you don't see the increments, right? You work hard every day. And then you look back a year and you say, wow, where were we a year ago? Let's see where we are today. And then you see the difference. So hopefully when I look back 10 years from now and I'll see what happened in those days, I would say, wow, that's amazing. I didn't think it would be even this way. But let's see. Have to wait and see.
Thank you very much for your time, Avi, and good luck for the upcoming future and the missions.
Thank you, Dorsen. It was a pleasure to be here again.
If you have further questions, reach out to us at radio@SpaceWatch.Global. If you like these or other episodes of Space Cafe Radio, leave us a rating on your preferred podcast platform. It is the currency of today. And if you want to stay on the pulse of the space industry, please visit our website at www.SpaceWatch.Global and subscribe to our newsletters. And of course, don't forget to become a Space Watcher. I'm Thorsten Triening, publisher at SpaceWatch.Global, your independent perspective on space.